Right. Today we'll be starting on the new chapter, which is a chapter on intermolecular forces. Let me first brief you on what these intermolecular forces are and different types of intermolecular forces and how to identify the intermolecular forces. So intermolecular, the term inter means in between the molecules. Intermolecular force, the forces of attraction which exist between the molecules is referred to as the intermolecular force. Now, if I'm to take, say, hydrogen chloride molecule, remember the intermolecular forces are found only between molecules, which means it has to be a covalent substance, right? Because ionic compounds won't form molecules. There are no intermolecular forces in ionic compounds because ionic compounds, they exist as giant crystal lattices where you have one cation around it many anions, and around each anion there are many cations. It's continuous structure, right? So this is a giant assembly of structure, assembly of ions, I would say, which are held together by a rigid, strong lattice structure. So that is many ionic bonds around each ion. So ionic compounds never exist as molecules. So therefore, there is no intermolecular attractions in ionic compounds. And also in giant covalent structures like diamond graphite, there is no intermolecular attractions because they are not molecules. So remember, the intermolecular attractions are found only between the molecule. Inter is in between the molecules, right? So if I'm to take a hydrogen chloride molecule, it's a polar molecule because the chlorine is more electronegative compared to hydrogen. So chlorine will develop a partial negative charge, whereas hydrogen will develop a partial positive charge. This is delta, plus delta and minus delta. This is a sign of delta to show a small charge. Now, if I'm to show another hydrogen chloride molecule, be like this. More electronegative will take a negative charge, electropositive will take a positive charge. And now there is attraction between these two ions. Positive pole of one end will attract the negative pole of the other end, the other molecule. So this is the intermolecular force which exists between these two molecules of hydrogen chloride. And these intermolecular attractions accounts for various properties of the molecule, properties such as the boiling point, the melting point, and the physical state. There is a solid, liquid, or a gas, all determined by the intermolecular force strength. And when it comes to giant covalent structures like diamond graphite, the boiling and melting point is determined by the strength of the covalent bond. When you take an ionic compound, the boiling and melting point is determined by the strength of the ionic bond. But when it comes to covalent molecules, the boiling and melting point is not determined by the covalent bond. It is determined by the intermolecular attractions. In covalent molecules, the boiling and melting point, or even the physical state, is determined by the strength of the intermolecular force. So it's an electrostatic attractive force. That is attractive force which holds two species with opposite charge ion, oppositely charged ions, like plus of one molecule attracts the minus delta of the other molecule, right? So intermolecular forces are of two types. If I'm to classify the different types of intermolecular forces, they are of two types. One is a stronger type, which is known as the hydrogen bond. It's so strong, we call it as hydrogen bond. It's strong as a bond, right? It's an intermolecular force, much stronger type. The other one is van der Waals. Van der Waals forces. It is named after the person Van der Waals, so it's named after him, right? Van der Waals is the person's name who discovered that type of forces. So van der Waals forces is of two types. You have the induced dipole attraction. I'll explain it shortly what this is induced dipole attraction means. And you have the permanent dipole attraction. The permanent dipole attraction is what I have drawn here. That is the attractive force which is between two poles. Because hydrogen chloride molecule, if you remember, we discussed on the unit 1 chemical bonding, it's a polar molecule, right? It's a polar molecule. So between two polar molecules, there's permanent dipoles. So one permanent dipole of one molecule attracts another permanent dipole of another molecule. Of course, opposite attractions, plus attracts minus, minus attracts plus. Because there are two permanent dipole molecules are involved, we name this type of intermolecular force as permanent dipole attractions. You had to mention permanent dipole twice because both the molecules contain permanent dipoles, right? So this is a classification of the intermolecular forces. So let's have extensive study on this induced dipole. I'll be explaining shortly what is this induced dipole, which is more stronger, how to determine which one is more stronger. All those we'll discuss shortly, right? Okay, so we'll go back to the etude. The first question, what is the electrostatic attraction between opposite poles of molecules, which gives ionic character to covalent compounds and also responsible for the phase change referred to as, you can say, intermolecular attractions. Intermolecular attractions. What are the two main categories of intermolecular forces, right? Van der Waals forces. Van der Waals. Make sure your spellings are correct. Van der Waals forces. And second type, hydrogen bonds. Second type is hydrogen bonds. The two types of Van der Waals forces present. Let's write the two types. First type is induced dipole. Dipole dash induced dipole attraction. I'll be explaining shortly what this induced dipole is. Second type is permanent dipole dash permanent dipole attraction. Second type, permanent dipole attraction. Right. So we'll go back to the previous example of hydrogen chloride. Hydrogen chloride molecule, it's a polar molecule, right? Polar molecule meaning it has permanent dipoles. That means dipoles are permanent. Always chlorine is negative and hydrogen is always positive. These charges, there is no change. So negative chlorine can attract the positive hydrogen. This is why we call permanent dipole attraction for HCl. Now, this molecule has two types of attractive forces. You can see the covalent bond here, right? Covalent bond. This is the covalent bond. This is a covalent bond, right? So covalent bond is also a type of attractive force. It's an electrostatic attraction between the bonding pair of electrons and the nuclei of the atoms. But this is not an intermolecular force because it's not between the molecules. Inter means between. Like we have inter-school match, right? Between the schools. So intra, right? Intra-school match. What is intra-school? Intra is inside. That means maybe between your houses, right? For example. Right? So this is intra. This is an intramolecular force. Intramolecular force is a force of attraction, which is a covalent bond, which is found inside the molecule. And intermolecular force is the attractive force which is found between the molecules. Now, the intermolecular force, as you see, is a weak electrostatic attraction between the plus delta and the minus delta, whereas the intramolecular force, it's very strong. It's a covalent bond, because covalent bond is the attractive force between the shared pair of electrons and the nuclei. And this attractive force is very strong compared to intermolecular force. Always the covalent bond, the chemical bonds are much, much stronger compared to any type of intermolecular force, including the strongest type, which is hydrogen bond. So in short, no intramolecular force is weaker than intermolecular force. Intramolecular force, which is the covalent bond, is always strong than intermolecular force. Am I clear to everyone? Okay. So we write the answer for that. Explain briefly why intermolecular forces are weak compared to intramolecular forces. Write the answer. Intermolecular forces are weak electrostatic attraction. Intermolecular forces are weak electrostatic attractive force. Weak electrostatic attractive force between opposite poles of molecules. Between the opposite poles of molecules. Whereas the intramolecular force is the strong covalent bonds which is between the atoms in the molecule. Okay, is that clear? Right. Any questions? So we can mention that as well. Therefore, intermolecular force is weak compared to intramolecular force. Therefore, intermolecular force is weak compared to the intramolecular force. Clear? Right. So the two molecules to attract, there should be some sort of electrostatic attraction between the two molecules. So when the molecule is non-polar, such as, for example, oxygen, hydrogen, or any of the noble gases. What type of intermolecular attractions exist between nonpolar molecules? Now, nonpolar molecules, there's no charge separation such as polar molecules. Right? Polar molecules have permanent dipole attractions, but nonpolar molecules also have a type of intermolecular attraction. There's no molecule without an intermolecular attraction. Right? So what is the type of intermolecular attractions which exist between nonpolar molecules? Let me take helium as example to explain this. Now, helium, I'm going to draw, it's a noble gas. I'm going to draw the electron density map of helium atom. Right, this is the A configuration. Helium has 2+ nuclear charge, and the electrons are symmetrically distributed around the nucleus. Helium has only 2 electrons, but I'm drawing here about 30-40 electrons here. Why? What this diagram called? The electron density map. What is electron density map? That is, the electron density map explains or relates how those 2 electrons of helium be present at a given time in the molecule. Right? So the 2 electrons can be anywhere in their orbital. Condition, symmetrical charge distribution. But these electrons are not in one place. They orbit around the nucleus. They are never stationary, right? They orbit around the nucleus. And the whole atom is also not stationary. They won't stay in one place. They'll just move. So electrons on the nucleus rotate. The whole atom also moves. So because of these 2 movements, these electrons can get asymmetrically distributed. That means one side will have more electrons than the other side. This asymmetrical charge separation can happen because of the movement of the electrons and the movement of the atom as a whole. Right? So this causes a charge separation within the molecule. The side where there are more electrons will develop a minus delta charge, and the side where there's less electrons, the plus delta charge. Right? So this situation is known as instantaneous dipole, which is also referred to as instantaneous dipole or instantaneous dipole. I'm going to draw the same instantaneous dipole over here. Right? And this instantaneous dipole on the left side will induce a charge separation on the other side, which means the side where are more electrons will push the electron, right? Will push the electrons from one end to the other end. This is known as induced dipole. It will induce a charge separation on the other molecule. Then what happens? The plus delta of one will attract the minus delta of the other. This is what is called the induced dipole attraction. So atom, nonpolar molecule, has electrons symmetrically distributed, and these electrons are not stationary. They orbit around the nucleus, and the whole atom is not stationary. They're orbiting, right? They're orbiting. And then what happens at a given time, this can happen. This type of, uneven distribution of electrons can happen among this rotation of the electrons or orbiting of the electrons. So this condition is known as instantaneous dipole. Now, not like the permanent dipole. Permanent dipole, permanently plus minus is there in the molecule, but this is like that. It's not permanent. This is temporary, right? And then when that molecule, which has instantaneous dipole, come close to a neutral helium like this, because this is already charged, that will induce a charge separation on the other molecule. That will cause a charge separation on the other molecule, meaning the one side which has more electron will push the electrons of the other molecule away from that molecule, developing a partial positive charge on that. So partial negative and the partial positive will attract and form intermolecular attraction. This is known as the induced dipole attraction. So